Okay, so what we're going to talk about, I'm going to show you how to do here is to come up with rectangular coordinates from these polar coordinates. And then we're going to talk a little bit about how to convert between polar coordinates and rectangular coordinates. So the first thing I want to show you here is that these rectangular coordinates, this is a problem that we just did, can be had by looking at these polar coordinates using our trusty trigonometry that we already know. So if we take this point, draw a little triangle, and we can use what we know to fill in the sides of the triangle. One thing we know about this triangle is that the r value is 3, so we know the hypotenuse of the triangle has to be 3. We also know that this is at an angle of 5 pi over 3, so that means the reference angle for this triangle is going to be pi over 3. So if we know an angle and we know a side, to find the rectangular coordinates, do you see that we want to just find the x value and the y value of this triangle? So to find the x and the y values, we just use the trigonometry that we know. We know that the sine of an angle is y over r, or opposite over hypotenuse. So we could say sine pi over 3 is equal to y over 3 in this case. And now we could solve for y. Multiply both sides by 3. We get 3 sine pi over 3. That would give us y. Looking at our unit circle, we see the sine of pi over 3 is root 3 over 2. We know that our y value is going to be 3 root 3 over 2. So if we put that down here, we see that it's actually going to be negative 3 root 3 over 2 because it's in quadrant 4. So now if we want to find the x value, we do the same thing. We know that the x value is going to be with cosine. Cosine of pi over 3 is going to be equal to x over r. So we say 3 times the cosine of pi over 3. We get x. So 3 times the cosine of pi over 3, which is 1/2, equals x. So x is going to be 3 over 2. So we put a value of 3 over 2 for x. So do you see that if now that we know our x value and our y value, at that point we have the rectangular coordinates? They're going to be 3 over 2, comma, negative 3 root 3 over 2. Okay, so now that we've found that, I want you to see a couple of formulas that come out of that. Do you see that when we found the y values, we took the r, which is 3, and we multiplied it by the sine of theta, and we got the y value? To get the x value, we took the r and multiplied it by the cosine of theta, and we got the x value. So in the future, instead of drawing these triangles, if you have polar coordinates and you want to find their rectangular coordinates, all you really have to do is take the sine of the angle, multiply it by r to get the y value, the cosine of the angle, multiply it by r to get the x value. So here's an example of using those formulas, r sine theta and r cosine theta, to find our rectangular coordinates. So if we look at A, we see that A has a polar coordinates r of 6 and theta of pi over 6. So if we plot those points, we get a point in quadrant 1 that's 6 units from the origin in the pi over 6 direction. To find the x coordinate, we take r, which is 6, and multiply it by the cosine of pi over 6, and we get 3 root 3. To get the y coordinate, we take r, multiply it by the sine of pi over 6, and we get 6 times 1/2, which is 3. So if we look at B, and then so those are our polar coordinates. 3 root 3, comma 3. So if we look at B, we've got negative 4, negative pi over 4, which means if we rotate towards negative pi over 4, we'll rotate into quadrant 4. We're walking towards quadrant 4, but since it's a negative 4, we're going to take 4 steps away from the point in quadrant 4. So you're going to actually end up in quadrant 2, right here. So if we take that point, negative 4, negative pi over 4, and we plug that into our formulas, x equals r, and we use negative 4 for our r, and we use negative pi over 4 for our cosine theta, we end up with negative 2 root 2, which is a negative x value, which makes sense for quadrant 2. Same thing with the y value. If we use negative 4 for our r and negative pi over 4 for our theta, the numbers will work out to give us a positive 2 root 2, which also makes sense for quadrant 2. So our coordinates, our rectangular coordinates for this point is negative 2 root 2, comma positive 2 root 2. So do you see that that's a little bit simpler and quicker than the method I did drawing the triangle before? So I hope drawing the triangle before showed you why these formulas work, but in essence you don't have to do the triangles if you remember these formulas.